Okay, good morning, everyone. My name is Ana Paula Furla, and I am pleased to introduce Dr. Andrei Razakamanantsoa to you guys. And he is a research and director at the Geomaterials and Environmental Interaction Laboratory of Gustave Eifeel University in Nantes, France. I can say he's my colleague because these partnerships are already almost 10 years old. I went to Nantes the first time in 2014 for the first time. After that, I came 3 times, 2019, 21, 23. And my PhD student, Mateus Francisco da Silva, did that postdoc in Nantes, supervised by Andrei Razakamanantsoa. It was possible due to the grants from CAP Sprint and CNPq. Andrei is a PhD in environmental geomechanics from the National Institute of Applied Science in Lyon, France. He is specialized in porous mechanics, multi-scale study of hydromechanics and chemical behaviors of geomaterials and durability. His major research topics are geomaterials and soil and atmosphere interactions. That's it. It's so good. And now I invite you to speak to us about university and your work. Thank you. And I am so happy for you are here in Brazil with us.
Thank you very much, Anna. And I'm honored to be with you today because it's a great opportunity to be with you in Brazil. It's the first time for me also. And I am very pleased to be here with you because I see I've experienced many things, interesting things in Brazil since I'm here. And so it's a great pleasure for me to talk with you today. I say talk because I will talk about the university, my university. I will talk also about the Department of Research and mainly the main topics of research that I lead in the University of Gustave Eifeel. So with Anna, it's a very long history. I mean, an interesting history because we work in a very interesting topics that I will talk a little bit also in my speech. So I will go ahead if you agree. So this was a presentation, but first the outlines, as I say, is that I will present the universities first, and after all the department and my own department and the laboratory where I come from. You can stop if my speech is not clearly okay. So I come from University Gustave Eifeel. Gustave Eifeel as Eiffel Tower, if you want. So at the beginning, University racine of University Gustave Eiffel was LCPC, Laboratoire Central des Ponts et Chaussées. As the name, it deals with bridge and infrastructure in civil engineering. The first step, it was been since 1949. And after, the first fusion was with INRETS. INRETS is an institution in France who works on crash test, security, safety, road, and all things related to that. And LCPC becomes IFSTAR. And after, in 2020, the second fusion was in between IFSTAR and UPEM. It's a university in Paris, Est Marne-la-Vallée, in Paris. to get University Gustave Eiffel. University Gustave Eiffel is unique, not because I come from, but it's unique because it's the only one university in France that we have. It's like USP in Brazil. You have in Sao Paulo, Sao Carlos, and in many places in Brazil. It's the same for University Gustave Eiffel. That is one matching point. Second point is that it's the only one university in France hosted by two ministries: education, higher education and research, and ecological transition and territorial cohesion. That means we have fundamental aspects of research and at the same time also an action to help the public action. For example, if we, most of the time we are consulted by the ministry, the government for such a decision, if it's good or not, and something like that. So, University Gustave Eiffel is composed by 23 departments in 7 campus. It's not a huge university. It's a small university because we have 17,000 students. I don't know for USP, I think you are more. Yeah. So it's it's quite small university. And the difference between standard universities, that we have a center of research and we have also a center for teaching. It's not mixed every time. So that means we have the staff of universities are a little bit different than a common university. I think you have similar. The University Gustave Eiffel is, I say it's a vision because it's innovative in France. It's the first time that we have something like that. Ah, okay. You are too small. So the idea is to prepare for the transformation and sustainable adaptation of cities and territories. Why? Because tomorrow we will be more and more in terms of demographic, and we want to use less, to consume less, and to be okay with the environment and so on. These things are something that we have to prepare. So this is a vision to build University Gustave Eiffel. As I said previously, that University Gustave Eiffel do fundamental research and applied research at the same time to help for important decision. One thing that I want to say, but I think that it's the same also at USP, is that one of the aim is to share knowledge for the benefit of a society. I say that because most of the time when we do fundamental research, we are not obliged to talk with everyone. We try to, for example, when we meet someone, we try to explain what we do. Most of the time, people don't understand what we do. So it is one of the things that when we are able to explain in a simple way what we do, which is complicated, it helps many things because to go ahead. So making science accessible to society, it's one of them, and also to integrate research into the socio-economic fabric. I mean, for example, if we work with a company need to make benefits. But if we give a hand, the benefits can be economic benefits, but also social and scientific benefits. Okay. If we talk about Europe, the link between University Gustave Eiffel and Europe, we are linked with in a cooperation agreement and exchange agreement. Exchange of student, exchange of researcher, and so on, and also in master 2 or in PhD or postdoctoral position. We need to do that because we are small in terms of quantity, and the exchange allows us to exchange in terms of scientific, in terms of application. It's more interesting to work with worldwide. And in Europe, we are we have a very wide collaboration, as you see. There are some names of agreement, cooperation agreement. In international position, as you know, TRP, Transperson Research Board, we are a member of this, and we have also a different research federation. I mean, different laboratory all around the world. We work in different topics concerning each countries, for example. The aim is to federate force and knowledge in order to reply to a specific problem. The idea is to gather the researcher and also means for to do research. For example, as example that we know with Anna, a part of experiments is done in Nantes, a part is done in Sao Paulo, because we don't have access to such sometimes to directly to some means of experiments. And we exchange a lot also. We use internet to exchange to have a meeting with the all people all around the world. Yesterday, for example, we have a meeting with Belgium to say that it's very wide exchange and dynamic exchange in terms of scientific point of view. Okay, so with Anna, we are in an international hub, which is called Waste to Wealth. Mean to reuse the waste in different terms, bio-based material or mineral materials, and to transform in valuable material in civil engineering. For example, we work with sediment, dredge sediment. We work also with lateritic soils. We don't have lateritic soils in France. It's a problematic for tropical soil. But we work together, and it's very interesting because we see things in different ways. It's like in front of a mirror, but we have also the back of mirror, and it's very interesting in terms of exchange. Now I will talk about my campus in Nantes. If you remember the map of France, Nantes is in the west coast of France, where you have rains a little bit, no more sun as you have in Brazil, but it's very nice. So the site of University Gustave is something like that. It's a huge campus with less people, because we are mainly more or less, less than 400 researchers and student all years, and we have a huge spaces. We have 7 buildings, and why we have huge spaces? Because we have a very interesting experiment device, for example, to test the traffic, to test different type of geolocalization system, or new bituminous materials, or acoustic system. Many things can be tested, and in France, it's one of the first site of a research center where we gather in the same place all of those experimental devices. So, as I say, we are 4 departments of research in Nantes. My department was one of them. If I talk about the key topics, I mean the research of Nantes, we have infrastructure and energy, because we are close to the seaside, so eolian, urban problems also, and mainly environment and risk issues, where I am involved in these aspects, and circular economy. And I talk about innovative infrastructure and mobility because IFSTAR comes from LCPC, if you remember the first time. So it's obvious. But for the rest, it's less obvious. So I come from the department GERS, Geotechnique, Environment, risk, Natural Risk, and Earth Sciences. So in this department, we have four main topics of research where different laboratories involved: geophysics, geotechnical engineering, urban and environment, and the risks mainly. So the department is like Gustave Eifeel. We have one laboratory in Paris, 4 laboratories in Nantes, and 1 laboratory in Paris. If you take a look about the map, we have the smallest laboratory in the department GERS. We are small, but we have different collaboration, international collaboration. That's why we are small there, but the main activities we do in international way. I mean, so now I will talk about our laboratory, geomaterials and environmental interaction laboratory. So I will insist about geomaterials. What is it? Geomaterials is materials that used in construction. It can be civil engineering or geotechnical application. The interest for us is mainly in geotechnical application. Okay, so in the following presentation, I will talk mainly about geotechnical application. So the originality of our way of working is that we most of the time we come from matter, from atom to the full-scale infrastructure. The originality of our laboratories is that we work in all of the different scale, full-scale, multidisciplinary, and multi-physics. I mean, multi-scale because we go from the atomistic aspects till the infrastructure, for example, embankment, road, or dam, and so on. And you have laboratory scale and you have microstructure scale where we analyze, we observe the microstructure. Multidisciplinary because we work in aspects in different domains. I mean, hydraulic, physico-chemical interactions, mechanical interactions, because finally the mechanic behaviors of materials is a combination of hydraulic, chemistry, and so on. And multi-physics also because the interaction between the materials and the environment is multi-physics, because we have soil mechanics, solid mechanics, and fluid mechanics, if you talk about environment. So, as I said, you know what is geomaterials as in my definition. So the laboratory works in interactions inside the geomaterials and the interaction of the geomaterials with the environment. Okay, so I talk about multidisciplinary and multi-scale, so I switch them. Okay. In terms of research, I just give you an overall view. It's not an holistic list. It's just to show you that what type of topics we are working on. So, for example, development of a binder from waste or from a different for geopolymers and so on. But we try to develop a new eco-friendly binder which can be used for different complicated materials in all around the world. We have two complicated materials, which is clay materials and lateritic soils. Lateritic soils is in all the countries, tropical countries, except France, more or less. And clay is an universal material that we have a problem to, when you talk about transportation infrastructure, it's a problem. So we try to have an holistic view, federative way of to solve it, to give solution for such a problem. We try, but go ahead. We work also on dredge sediment. Why? Because today, in all countries in the world, we throw the dredge sediment in the sea. But it's not, it will not longer like that. We will have to try to use them and to use in a good way. Why we cannot use today? Because if you discuss with a company, they will say, we don't want to valorize the sediment because we are not able to build the valuable materials with. And we say we try to transformate the waste into wealth, and we work on it. Next one is about sustainable construction. For example, crude without. Most of the time we use baked brick. No, we will try to use like Mayan people who build their pyramid with soil without anything. Why we cannot do something like that today with a good technology? And after, last but not the least, the durability of structure. I mean, durability in terms of coupled stress or cyclic stress. This is about research, but we are university. We do also training. Training can be supervision of a group of students, or a course, or development of international course training, which is, for example, method class. And so now I will just tell some ongoing research in the laboratory to give you an idea about what we are doing every day, and sometime every night, because due to the difference of jet lag and so on, because we work with Japan at the same time with Brazil, and we are not. Sometimes it's so strange, but the strategy is that human need is a core, because before, when you build an infrastructure, we say that human will need that, but it's not, human is not obliged to use that. They need that. No, the idea is that to put the human and the need as a core, and we try to understand what is exactly the need of this human, and to try to propose something that will be used with this woman. This is a concept. And for that, we are in soil mechanics. So we have a soil, we build the materials, we build the structure, and so we will have transportation, for example. And after, we will have to think about the impact of this infrastructure that we build. And for that, if you talk about soil, we have soil mechanics first, because we prepare sample, we implement sample, and we try to verify them if it's okay in mechanical point of view. But as I said, mechanical point of view is a result of a combination of complex combination of mechanisms. And after, when you talk about interaction between soil and the environment, you have the soil matrix, which is compacted, and the traffic, and the environment impact, which is in the domain of fluid mechanics. And after, you have the impact of all of those structures in the health of peoples. For example, if you talk about soil, you have a powder at the beginning, and you have a compacted one, and due to traffic, you have a powder again, and you have air pollution due to dust emission, for example. It's an example. It's a shortcut, but it's an example that. So we work with different companies about that, and we try to companies and university to try to give a solution for all steps of this concept. So this is a concept. So in the aspect from soil to the infrastructure, we have the approach. We use microstructure and textural properties of porous media. So it's a porous media problem. And after transferred with microstructure and the matrix. And after we work with boundary layers, which is a problem of fluid mechanics. And after we work with health services and hospital about, for example, about the link between causative pathogen agent, which is fixed in particles and which cause some disease that is more and more common. We know about COVID, but COVID is one of the results of these interactions. So the idea is to show you a project, a research project from this in this way, from soil, implementation, infrastructure, and the degradation. One about microstructure and the textural properties of porous media. One example is that most of the time we do things in lab and we recommend to the company that you have to do like that. The exercise that we have done is that we come from field and we try to make a kind of autopsy and we try to understand why the material behaves like that by using microstructure. And for example, one of the main results that you have demonstrated is that when depending on the type of compaction materials that we use in field, we can have a different structure which is favorable or not to a good mixture between binder and the soil, and its result a different level of mechanical performance. In terms of flow, for example, also, depending to the mode of compaction, we can generate a different structure which improve the tortuosity inside the soil. So the water goes longer than without compaction, with a smooth compaction. Next step is about dust emission in field, for example. If you want to have an idea, 10 micron is close to our hair, so it's visible. So 2.5 micron is something that is not visible. It comes inside and go to our lung and cause cancer and so on. So we see that you see the effect of dust emission in the leaf, but you don't see what happens in our lung. So even if we don't have that, we try to work with different airflow companies and hospital medicine in order to try to understand the mechanism of dust generation till the impact in health, respiratory health. For that, we try to understand the mechanism of interaction by using tribology and all of the mechanisms in full scale and laboratory scale. At laboratory scale, we use, for example, wind tunnel to simulate the track, the passage of a track, and to try to reproduce this mechanism of turbulence in a laboratory. Why? Because today we are not able to understand understand well the mechanism of diffusion of particles as it is. In terms of training, we work with another university to try to, ways. The application that we use for road, what we try to build is an application for air quality. I mean, when you wake up in the morning, you check your phone where I have to go, by bicycle, by car, or by on foot, and we try to give best way to go. But the problem today, it's an universal problem, is that we have just an idea about the quality, but the hyper-local air quality we don't have. So we try to develop a different sensor in order to have more precise values of air quality. And we do that in France, we do that in Madagascar, and we do that in India also. It's an ongoing project. And this is in the same way. And this is involved in this project MadAtlas. It's for training. That's all, I think. As a conclusion, our research topic involves multi-scale, multidisciplinary, and multi-physics, involving microstructure and coupled phenomena, hydraulic, mechanic, and chemical. We aim to develop an international research federation, and we try also to develop materials which is low-tech, low carbon footprint, dedicated for transportation infrastructure. Perspective of collaboration is that we want, University Gustave Eifeel, and particularly me, we want to develop and to consolidate the ongoing collaboration, and even to wider with a different collaboration, which involves student, teacher, mobility, and training maybe. We try also, and we expect to develop international research federation, which border wider scientific questions, and to be able to apply for different project funding opportunities, which is not available in France, for example, because each country has their specificities in these aspects. And all of that in order to develop a dynamic research with applicative results. Thank you very much. Obrigado.
Obrigada. Do you know obrigado, it's for men?
It seems.
Obrigada, it's for
So-
me. Okay. Thank you very much, Andre, for the presentation. I want to say thank you very much for you all here, and for you all here. I don't know. And then next Thursday we have another presentation about scientific topics,
It's
and
more
then
research. This is an overall view of research.
yep. And after we can I don't know, give your mail address.
Yeah, of course.
Okay. Thank you, and bye-bye, and see you next Thursday.
Maybe if you have a question, any question before and after. Yes, right. Thank you. Thank you very much.
Bye-bye.